this is 6.4. Very easy. كله. It's literally all one formula about investing, and the final amount of money equals P times 1 plus R to the power of n. P is the principal focus, principal amount. It's the amount you invest. R is the rate of interest, and n is the number of years. When solving, any rate given is in years, and any time should be also in years. Okay, but you can solve it differently if you want to convert أكيد. ف yeah let's solve. P in this case is 12,000, since 12,000 being invested. 1 plus R. R is 4%, so that's 0.04 to the power of 10. I think everybody knows why I made the 0.04, because to convert from percent to decimal, you divide by 100. You put this in a calculator, 17,763. I think, do they say round? Yeah, to the nearest dollar. Question 2. 1,000 invested at a bank, and it triples in 20 years. What's the percent? So the formula is P 1 plus R to the n equals final amount. Okay, they're saying it's tripling, yeah? So it's 3 times 1,000, because it's tripling. The final amount is actually 3,000. Equals P. P is 1,000, because it's 1,000 being invested. 1 plus R. Do we know what that R is? No. To the power of n. We know that n is 20 years. Okay. Before continuing, let's cancel these zeros on both sides. You'll be left with 3 equals 1 plus R to the power of 20. We have to get rid of this 20, so we have to do the 20th radical of 3 on both sides. Okay, 20 cancels with 20, and the 20th radical 3, I'm not going to give you the exact answer, but you do it on the calculator. So you're going to get 1 plus R equals the 20th radical 3. So R will be equal to the 20th radical 3 minus 1. Yeah, other side. And you're going to get like a small number. You're going to get, I think, 0.05647 or something like this. And you always multiply it by 100, because we need to convert this decimal into a percent. Okay. Question 3. A principal of 12,000 is invested, and it gets you an interest rate of 4%. The interest rate that's given is always yearly. So they're compounding it monthly. And they're saying after 10 years. They want to compound it monthly. So each month it's increasing. So what do you do? It's the same formula. Final equals P 1 plus R to the power of n. Except this rate should be in months, but we have it given in years. It's always given in years, unless they say it's given in months. When they say compounded monthly, doesn't mean the rate is in months, no. So they have to say it increases by 4% every month. That's when you know it's monthly. But if they don't say that, then it's yearly. Okay, so it's going to be 12,000 1 plus R over 12 times 1 plus R to the power of n. Yeah, times times to the power of 120. Walid, what are you doing? Okay, why did I divide by 12? Okay, from years to months, okay, you have to divide by 12. If you want to convert from per year to per month, you have to divide by 12. Okay, however, when you're converting the time in years to the time in months, you multiply by 12, because there's 12 months in 1 year. It becomes 120. It's different. For the rate, you divide. For the actual power, you multiply. So R, we know, is 4%. It's 0.004. So 1 plus 0.04 over 12 times to the power of 120. And let me do this on my calculator and make sure it's correct, because I have a feeling I did something wrong. 12,000 times 1 plus 0.04 over 12 to the power of 120. Yeah, no, it's correct. You get 17889.99, which is the same. I just rounded 17890. Question 4. Amount of $550 was invested into the bank. It pays an annual interest rate of 7%, and is compounded annually, يعني عادي. To the nearest cent, the value of the money after 4 years. There's nothing sketchy here. You solve normally. Use P 1 plus R to the power of N. The initial amount is 550. 1 plus 0.07 to the power of 4, and you get $720. $720.939, I think, or something. They want you to round it to the nearest cents. I don't know why, but it's already given you. They gave you 94 cents, and you just take the 720. Okay. Okay, now this is 6.5. It's all about population, okay, and reduction and heck, this stuff. We have a formula for each one. The population size has a formula. The population size, the final population equals the initial population times 2 to the power of t divided by the rate. Yeah, that's it. So why am I saying 2? Because it's doubling. But sometimes they tell you triple. So you multiply it by p into 3 to the power of t divided by r. So it just depends on the question. Usually they say double, but I wouldn't be surprised if they got you triple in the exam. The time is usually in years, and the rate is also usually in years. The time in this case, if it's every 70 years, that means the rate is every 70 years. Okay, so time divided by 70, like this. This is how you write it. But the original equation is p into initial population times the rate, double, so 2 to the power of the time divided by 70, because that's the rate, every 70 years. المهم, it starts with 35 million, but let's just leave it as 35 because we're working with millions. I don't want to put zeros and be how can I say هيك. I don't want to ما بدي لبك حالي in Arabic. I don't know what to say in English. المهم, if we're starting in 2012 and we're finishing 2222, how many years are in between that? That's 210 years. Okay, so the time is actually 210. So 2 to the power of 210 divided by 70, which is just 3. You have 35 outside. This is 35 times 8, because 2 to the power of 3 is 8. You get 280. Question 2. Wait, let me write this down actually. Population growth for doubling. It's P final equals P times 2 to the power of t divided by the rate. Yeah, that's it. Because there's a few more. Okay, a certain type of bacterium divides every 20 minutes to produce 2 bacteria. A certain colony started with 20 bacteria. After 10 hours, there will be 5 times 2. So, okay, look, it's dividing every 20 minutes. For the rate is 20 minutes to produce 2 bacteria. Okay, so it's doubling, right? Every time it's doubling. We can use the same rule, P times 2 to the power of t, except over 20, because the rate now is 20 minutes. A certain colony starts with 20 bacteria after 10 hours, whatever. Okay, one thing to know, we're starting with 20. For the initial population is 20 times 2 to the power of t over 20. The time is in hours, but the rate is in minutes. So we have to convert this 10 hours into minutes. That will be 600 minutes, because you do times 60. So it will be 20 into 2 to the power of 600 divided by 20. So it's going to be 20 into 2 to the power of 30. Okay, so 20 times 2 to the power of 30 If you put this in a calculator, you get a big ass number. But what you have to do here, this is what's a bit annoying in this question. They want you to keep the power of 2 alone. Okay, and now simplify it that you get 5 times the power of 2. So 2, let's take just the 5 out, and they want you to take the 5 out of this 20. It will become 5 times 4 times 2 to the power of 30. Right? Because 20 is 5 times 4 times 2 to the power of 30. What is 4? 4 is actually 2 to the power of 2 times 2 to the power of 30. So it's going to be the same as 5 times 2 to the power of 32. Because 30 plus 2, 32. That's why. But I know it's a bit it's a bit confusing. I don't know why they do this. Even our math teacher told us no. It's pointless. I don't know why they do this. The important part is the formula. If you get an exact answer in the form after finding the formula, a decimal, that's accepted. But I don't know why in the computer they do this. And let me continue. Question 3, I think now it's the decay. Okay. For the decay, the rate of decay, and the bacteria, and the elements, and half-life. The actual formula is Q final equals Q initial times E minus RT. QI or Q naught times E to the power of minus RT. This is the formula. You have to memorize this, okay? But I'm gonna give you another formula to make your life easier. Usually when solving these questions, you need the rate of decay, which is R. Okay, you usually need the R. I'm gonna give it to you very easily. R is equal to, R is gonna be equal to ln of what they're asking for. Yani, how can I say it? Ln. In this case, like when they're saying half, you'd say 1/2 over the time. This is the formula for R. Not time, sorry, it's minus time. Let's apply this here, okay? The amount of sodium 24 present at any time is reduced to half of its size in 15 hours. What would 1 kg of this material be in 90 hours? So we want to find 1 kg, right? So Q equals Q node times minus RT, or Q final, whatever. This is the formula. But you need this R to solve. For أول شيء we have to find R by doing ln half over minus 15, because that's the time here. So you get R. Let me actually do it. I hadn't do it. My calculator. Ln half over minus 15. You get 0.0462098120. It's a long number, yeah. Let's keep it as 0.0462. Can you solve now? Yes, you can. Q equals Q node. What are we starting with? 1 kg, right? They want the answer in grams, so let's convert this into grams and put 1000 times E to the power of minus 0.0462 times 90. This is all in the power section. This is a function on the calculator. You can find it. It's on the top right side of the calculator. And also ln is also on the top right side. If you press shift ln on my calculator, if you press shift ln, you get the E. And I have if I press shift ln, I get E, and if I press it's on the right side of the calculator. You put this in a calculator, 1000 times E to the power of minus 0.0462 times 90. You should get a number. Wait, let me do it actually. 1000 times E to the power of negative 0.0462 times 90. you get 15.6, and once you round that, you get 16. Question 4. يعني ايش الفورمولا صراحة. The half-life of radium is 1600 years. Suppose that at present there's 1 gram of radium 226. About how many grams were present about 5000 years ago? Again, we need the rate. Always need the rate. The rate in this case is going to be ln, and since we're saying half-life, for half over minus t, so minus 1600. And you get, let me do it, minus 600. You get 4.332169878 times 10 to the power of negative 4. You get a, again, very long number. For let's just put it as 4.33 times 10 to the negative 4. Okay, that's your rate. Now can we find how many grams were present 5000 years ago if we're starting with 1 gram? Q final equals Q node, which is 1 gram, times e to the power of minus 4.33 times 10 to the minus 4 times minus 5000. Why are you using the time as minus 5000 years? We're saying 5000 years ago. We're talking about the past. If it's in the past, if you multiply by minus 5000. And let me do this on a calculator. 1 times e to the power of minus 4.33 times 10 to the power of negative 4 times minus 5000. You get 8.714 on your calculator and round it to the nearest gram. That's 9. Okay, question 5. Suppose that 500 milligrams of thorium-234 are reduced to 410 in 1 week. What is the half-life of thorium-234? Okay. أول شيء, to find the half-life, it's a time, you need to find the rate of decay. Okay, so we know that 500 went to 410 in 1 week. The final is 410 equals the initial, which was 500, times e to the power of minus rt. We know that the time is in 1 week. We want it in days, so it should be 7 days. Okay, so 410 equals 500 e to the power of minus 7r. Let's solve this. 500 to the other side. 410 over 500 equals e to the power of minus 7r. Whenever you have a power, you can't solve unless you take ln on both sides. Okay, you have to take ln of both sides. Ln, it's a function on your calculator. Okay, so why do I do this? Because I need to take this minus 7r down. I need to take it out of the power. So this ln function actually cancels out this e. It cancels out the e and it brings this minus 7r down. So you're going to be left with ln of 410 over 500 equals minus 7r. So r will be ln 410 over 500 divided by minus 7. And you should get ln 410 over 500 divided by minus 7. You should get 0.02835, something like this. So 0.02835. Let's say it's this type. Now that we know the rate, we can find the days. Half-life. Half-life. What does this mean? It means that the final is half of the initial. So you know we say Q final equals Q initial times e to the power of minus RT. In this case, the final is actually half of Q initial equals Q initial times e to the power of minus RT. Okay, we can simplify a bit here. Qi with Qi, you'll be left with half equals e to the power of minus RT. We know R is 0.02835, so half equals e to the power of minus 0.02835 t. Now again, we have to take ln on both sides because we need to take this power down. So you'll get ln half equals 0.02835 t negative. How would you find time? You take 0.02835, you divide. So t equals ln half over negative 0.02835. Let me see. Ln half. You get 24.4. Yeah, you get, and I got 24.4 on my calculator, but you should get something around 24 days. Okay, it's just a formula. صراحة. Why we didn't apply the rate equals ln half over negative t? Because here they didn't tell us it was half-lifed. They only said the mass decreased. But you actually have to use the full formula. Yeah. You have to use the full formula. Part B. What would 500 milligrams be reduced to in 30 days? We know the rate is 0.02835. Q final equals Q initial, which is 500, times e to the power of minus RT for 0.02835 times the time, 30. Put this in a calculator, let me see. 500 times e to the power of minus 0.02835 times 30. You get 213.6, which is rounded to 214 milligrams. That's it. Thank you so much for watching, and good luck.